All right, so now we're going to be looking at sample problem 4.2. Just do this. In sample problem 4.2, we're going to be looking at the beam that we see here. There are 3 loads on this beam, okay? They're applied. The beam is supported at a roller at A and a pin at B. Neglecting the weight of the beam, so they're not telling us to worry about that. Determine the reactions at A and B when P is equal to 15 kips. 15 kips. Kips is 1,000 pounds. There's nothing here to, do anything with as far as multiplying by gravity. This is already in units of English force, if you would. So it would just be 15,000 pounds, but instead of all the zeros, we say 15 kips, okay? So let's go ahead and draw our free body diagram of what we have here, and then we're going to add our reactions at our supports. So we've got point A, and then B is right about here. I'll add that after I get my forces in place. P is 15 kips. And then we've got 6 kips and 6 kips. Mm-hmm. 3 feet, 6 feet, 2 feet, and 2 feet. Be above here. Don't forget your convention. So these are my, what we call applied loads, all right, that are identified in the problem. Now we want to put our reactions at our supports. Roller at A. How many reactions there?
1.
1 reaction perpendicular to the surface it's riding on. So we have to look back. The surface it's riding on is horizontal. So at A, this is going to be vertical. So this is AY, okay? B. B is a pin. How many reactions at a pin?
2.
2. What directions?
X and Y.
X and Y. Excellent. Oh, so fun. See, it's like you're listening when I talk. It's amazing. Just kidding. So now, X and Y, I'm going BY going up because my external loads are all going down. We'll confirm that direction. And then I'm going to show my BX going to the right. Again, probably going to be okay. All right. So that's everything that I need, right? So this number 1, my free body diagram, I think I'm good, right? My distances, I have my loads, my applied loads, and now my reactions at my supports. Now I am ready for step number 2, my equations of equilibrium, okay? So we'll start with some of the forces in the X. Let's get that X, BX out of the way. So sum the forces in the X direction equal to 0. I've got BX is equal to 0. Box around it. That is a reaction at our support in the X direction. Okay. Then I'm going to sum my forces in the Y equal to 0. Positive AY minus 15 kips, positive BY minus 6 kips, minus 6 kips, equal to 0. Okay. I always want to see the separate forces on a line so I can see your positives and negatives. Don't just combine them all together and then put a number yet, okay? Show me, I should see as many numbers as you have forces in your diagram, okay? So resist the urge to take 15 plus 12 and just go negative, okay? I want to see the separate forces. Just in case that number is wrong, then I know where it came from, okay? So now I can combine the items that I have here. So 15 and 12. So I have a negative 27 kips plus AY plus BY is equal to 0. I'll put that to the other side. AY plus BY is equal to 27 kips. That's as far as we can go with that one, but we still have sum the moments, right? Now, I believe that you guys are kind of like getting the hang of this. So go ahead and solve for AY and BY. Okay, I'm gonna let you finish this problem and we will compare. I'll do it on the side here, but you can, peek if you need to. I'm gonna sum around A like I normally do to get the BY and then substitute BY back up. As you're working, you should end up with BY equal to 21 kips. I ended up with a positive value. So the direction of up is correct, okay? Then I plugged it into my sum of the forces in the Y equation, and I solved for AY as 6 kips. Again, a positive value, and the final answer meant that the direction of going up that I assumed was correct as well. So didn't have to change anything there. So those are the final answers for sample problem 4-2. Okay. Any questions on that before we put that one to bed? Okay, good. I'm going to stop the recording here.